So begins the YouTube stream. I hope. Oh, I didn't have a mic down the desk. Dang it. This here, right in my face, so I don't forget about it. Okay. That. Classroom. Algebra. Share. Video. Stream. Add. Link. Post. Good. Discord. Nobody's here. We're expecting anybody here. We're not, that's right. It's just you three. So no Axel? Haven't seen him. I haven't either. He wasn't in class with us this summer. I've never met the guy, to my knowledge. I don't know. Maybe I have. Okay, remind me, which is which? Viviana, Arlene. Okay. There's Arlene. Good. So it looks like we have nobody online. Sweet. Okay, well then I'm just gonna disconnect from Discord. Somebody shows up later and yells at me. How'd the stream go? It was okay. All right. I should say a few resources. Hello, good morning. Welcome to like the real start of the year. We kind of unofficially got started in the summer, officially, unofficially, but I never really introduced myself. You got to figure it out the hard way. So, in case you didn't catch it, my name is Mr. Apple. I have a slide here that you can read if it ever decides to get there. There it goes. Okay. So I went to University of Notre Dame, studied physics. It was awesome stuff. Decided I wanted to teach. Went to Concordia, Chicago. Got certified to teach math and physics. It's all very related. I'm sure you can imagine. Guess what kinds of things I like? Batman is one of them. Yeah. Obviously, he's a cool guy, right? He doesn't have any superpowers, but he can keep up with the people with superpowers. That's pretty incredible. That's something worth striving for. Be like that. I like games and learning, and I do try to combine the two as often as possible. We'll see what we can do with this strange year ahead of us. In a sense, I view the online learning as an opportunity. We're going to stick with using Khan Academy pretty heavily as our main exercises and just practice for the day, which means it kind of frees us up to do some different stuff in class, or at least online during the class time. Right? So maybe we can play more math games. Great. Again, I'm always available for questions. Doesn't mean I answer at midnight because I might be asleep, but you can always send me an email or look at the Discord. If it shows that I'm online, then I'm online. That's better than everybody's got a bias. Okay? Everybody comes from somewhere. I prefer to just be upfront and let you know ahead of time. So this is a Catholic school. I, however, am Lutheran. That's one of the Protestant denominations. I believe pretty much all of the same major things as Catholics, except I don't think the Pope really has anything to do with it. It's a big simplification there. I'm a libertarian politically, which means I don't like the Republicans or the Democrats. I'd rather there be a third option. So that's where I'm coming from. I think you've already got a feel for my style and personality. Okay. The other thing I didn't get to do this summer, we just jumped right in. Who the heck are you? I don't know anything about you. Besides, Viviana. No, they didn't rhyme. Viviana Arlene. So, stand up. Introduce yourself. You got to stand and present, right? It helps with the diaphragm. When you're down here, your diaphragm's crunched. You got to stand up, free those muscles so you can power through that mask. It'll muffle you. And I want you to tell me who you are and what makes you awesome. Right? Come up with something you're proud of, right? Something, I know a bunch about this topic, right? I used to study this, or I know how to do this. You got this skill, this accomplishment. You did something cool this summer, right? Help your siblings with their e-learning. Oh, that's good for you. Yeah, no, that's good. That's awesome. Right? Some people, they hate this. No, that's your problem. Sorry. But you're such a wonderful, caring person. You help them out. That's great. Right? This is the kind of skill you're going to need. Okay? You got to be able to go into an interview and be like, hey, you need to hire me because I'm incredible. You need me. Right? All right, thank you. Next.
So, my name is Arlene. I think something that makes me very this is that I'm really open-minded, so I like to see stuff from aspects. I also like seeing different types of cultures. I'm very interested in very
That is awesome. Open-minded, want to see different perspectives, learning about other cultures. That's incredible. Yeah, people will love that, right? And that makes you a better person, right? And anytime you share something like that, like, I do this thing and it's awesome, be like, everybody should think, oh, that's cool. I want to do that. I want to be like that. Yeah. Make them a little jealous every once in a while. That's okay. Just a little, right? Okay. That was quick. So short. Such a small group. We took one large class, cut it in two, and then took that half a class and divided it into three. Jeez. All right. It's going to be fantastic. We're going to speed along stuff this year. It's great. Okay. Do you remember Dr. Odiati's analogy and the announcements where he said, life is not an elevator, it's a staircase? There's no shortcut, there's no easy way. Okay? Love this analogy. Staircase is too easy. Okay? Staircase, yes. By the time you get to the top, you're tired. It takes physical effort to climb all those stairs. Fully acknowledge that. But staircase is a nice, clear, clean path. It's straightforward. You know exactly where you're going. You can see it along the way. There is no thought, no issue required. It's just repetition, one step right after the other. That is not life. Okay? Life is a rock climbing wall. Right? You don't know where you're going exactly. You have no idea how to get there until you've tried it already. You're looking ahead and like, this handhold, maybe I'll try this one. And, ooh, that one looks easy. I can grab hold of it. And then you pull yourself up there and you realize, oh wait, there's nowhere else to go from here. Back down, over the side, try another path. You got to figure life out. You got to think and plot and plan and change those plans. And especially this year, they've taken half the handholds off the wall from us. Okay? It's a challenge in every possible aspect. And you might slip, you might fall. That's life. Thankfully, we've at least got somebody on the rope. I thought that'd be teachers, right? Got the rope. While you're here in school, we got you. You can make mistakes. You can slip, you can fall. We'll catch you. Right? You're learning. We're practicing on the wall. It's going to come at you hard. All right. That's my spiel for the day. Let's talk math. Here's our master's schedule. This is on Google Classroom. You should be looking at it early and often. Our objective for today is to continue with our TI-84 theme of the week. This wonderful new tool that we got physical ones last year. It was an amazing upgrade. And then, of course, I can't share them with you. But you have an app on your Chromebook, right? You tried it out. You did the scavenger hunt yesterday. Got a feel for all the buttons and where things are. Excellent. We're going to continue with that. And we're going to practice the graphing aspect because that's the big upgrade. This is the graphic calculator. It's not the baby scientific calculator, right? And that's the entirety of the day. I've got a massive graphing challenge for you to tackle today. Where's my mouse? There it is. It looks like this. So, on Google Classroom, you can find a copy of this document. This is the graphing challenge. You're going to graph all of these functions on the calculator. And then do you know how to take a screenshot on your notebook? Can you do the selected screenshot? Yeah, even better. Then you can just do the screen of the calculator. Right? Just pick that and then stick it in the document next to or underneath each of those. And then turn it in where they all are. Equation, graph, equation, graph. Right? They get harder as we go. Since I don't have the Discord running, I am going to go ahead and attempt to bring up my calculator app and try to show it on the board. Let's do a little bit of it. But at the very least, if we have to, I do have that poster. I can point to some things. I'll bring that over here so it's at least on camera for the recording. Yes? There's a plus sign at the beginning. Oh yeah, yes. Very good. Yeah, clearly you would not want to actually take in that plus sign. That's excessive and unnecessary. Can you see why in creating this document I may have left that plus sign there? Anything seem fishy about number 8? After having gone through 1 through 7, and then you get to 8. Come on, if you can't spot this, we're going to have problems. Notice about these functions. Except, yeah, same thing, I swapped all the signs. Yeah. And then, of course, not really thinking about the checking in part. Swap is still positive, and I don't need to write that part. Okay, app is up. I can put it on our screen here. And now, let's see if we can capture that. Hey, there it is. All right. Good, so we should have that on YouTube as well. Excellent. All right, so if you've never done these before, all of your graphing will start in the y equals button right here. And that will take you to this screen where you can plot multiple functions, right? Each of these, I can put one here, y equals this, y equals that. Notice that means in order to graph anything on this calculator, you have to rearrange your equation into a y equals form. You can't leave it in some standard form or some other thing. Right? Type in what you like. What do you want to graph? Because this is the color edition, the arrow over your cursor. The arrow keys here. We'll highlight the equals symbol itself, then I can turn on and off that graph and say, no, I don't want you to graph this one, just the other one. And go over here. And I can use this to change the color and line type. So if you want to make a dashed line on you, leave this one to blue, red, green, whatever. Color code that if you like. Very handy. Okay. The other thing you must be aware of when you're graphing on the graphing calculator, especially if you're used to, say, Desmos graphing. Right? Desmos takes advantage of the more modern technology, right? Being on a computer, you can freely move around the screen and the view. The calculator doesn't do that. There is no scrolling the view on the calculator. You have to set the window. Okay? So what the calculator will do is it will create the graph for you. But between you and the graph is a wall. Okay? Just like this. Big piece of drywall. And so what you also need to do is go to the window and tell it, where do you want me to cut the hole for a window so you can look through the wall and see the graph on the other side. best analogy I can do. Okay? So by default, it's going to say, I'm going to start my window horizontally, x min x max. On the smallest x value be negative 10, biggest x value be positive 10. I want you to scale it by ones. You graph by hand before they make all the little tick marks. Maybe you have to graph it something really big to only make a tick mark every 10, 20, 30, 40, 50. That's what scale means. SCL scale. Okay? And then you do the same thing for y. How tall do you want your window to be? Now, of course, you don't have to eliminate these. If you know for a fact that this one up. The interesting bit is going to be in the first quadrant. Maybe you adjust the window from 0 to 10, 0 to 10. Min-max scale, that's about all you'll ever see. I can never touch these numbers. Now, that's the manual way, if you know what you want to look for. However, it does have some predefined features in the zoom menu. So you can automatically, you make a window, you go, oh no, that window is too big, zoom in. That window is too small, zoom back out. Or in looking through the window, you can decide, no, I don't like that window, I would rather the window be here. You can use a zoom box, and then you get to click and drag, kind of like when you click and drag on your desktop, and there's a little box that highlights all the icons. And you click and drag, and you can get a box and say, zoom in on this section. When you're first starting out, I recommend these two, 5 and 6. Z squared and Z standard. Z square will adjust it to compensate for the fact that the screen is a rectangle. It squishes it a little bit. Z0 will be Z standard. That's what gets you back to the negative 10 to positive 10, negative 10 to positive 10. So I would always start there. Look at the Z standard. See what that looks like. Most things are going to have stuff happening. Most equations we look at, we look smaller numbers, closer to the origin. But if you don't see anything interesting there, and instead you can go all the way to 0, zoom fit. And this will let the calculator automatically decide where it's best to show the window in order to display the most interesting bits about the equation. Usually does a fairly decent job. You think about what you know about a quadratic parabola. You definitely want to get that scoop, that bottom midpoint where it makes the sudden turn. Zoom fit will find that for you. Way off negative 20, positive 40. And it will zoom in and it will fill the screen with the curve. It's great at doing that. I had a line there last time, so there you go. There was my line. No idea what that equation is. And then when you've done the first half, we go to the advanced version, and we get to see the really cool stuff. To do that, you have to go to your mode, and you change it to polar. Okay. You go down to where it says function, and highlight polar. And if your calculator is not already, the one above that, make sure you're in gradients, not degrees. Alright, so when I set my calculator to polar, now the y equals is going to look different. It's not y equals anymore, it's r equals. And my window becomes even more critical. Polar coordinates are circular. Right? Just to give you a real quick and dirty summary. Polar coordinates, instead of x, y position, I'm this far vertically, this far horizontally. Polar coordinates has r, the radius, right? How big of a circle, how far away from the origin are you, and at what angle. Right? So think like ship navigation by compass. Right? You can't track your x, y coordinate. There's no horizontal, vertical out in the ocean. You have a compass, and so you're basing on angles. Polar coordinates are more important. Right? At that angle, go that far. You're no longer on a grid of streets. Those far. So your dependent variable now is the angle. If you were to plot just a circle, you would set r to a single number, just radius of 2. Say, okay, I'm this far from the origin. Well, how many turns do you want to go? You want to go all the way around the circle, you need 2 pi radians. If you want to go multiple times around the circle, you can crank this up every time. You can go backwards in the circle if you set this to 0 and make this negative. And then again, the step, it's not so much the tick marks on the axis as it is how far do you want the feather to jump before actually drawing the next point. So setting your window for the theta is much more important for the polar ones. That's why on those polar graphs, it gives you not just the r equals function, it also tells you what to set the theta equal to. And if you do that, you will create some really cool pictures. The regular functions, you get lines and curves, and they go really, yeah, that's okay. But this doesn't mean stuff because we're contained to always wrapping back around that origin point. It doesn't just take off in the direction. So, play with that. Create pretty pictures. Feel free to tweak the colors. I think is it the color edition? Does it actually have the color settings on the graph? Yeah. And that's it. Unless you have any questions at this point. Well, then it will be now on this. So the first code was out live during the class session. So I broadcast it, so if you use the broadcast to see it. And the rest of the period to work, which is, how long is that, 12:15? So about 20 minutes. Okay, even that, broadcasting the talk. Awesome. So please do that. Let's try that one. Okay, so R1 would be 4 cosine of 4 sine of 4 cosine. I'm getting the pattern here. 4 sine of 4 cosine. How many times did I do this? Four pairs of a tangent. One pair, two pairs. Oops. Three pairs. Four pairs. And one more for just tangent of theta. And yes, we use the same button for all of the variables. The x, t, and theta, when you're putting in the radians. It's the same button you use to type in the x. Right there next to alpha. 1, 2, 3, 4, 5, 6, 7, 8, 9. Morning. Four cosine cos 3 cos 3 tan. Okay, cos tan theta 1 2 3 4 5 6. There we go. And we actually need to turn these off. These are not graphed. And then R3 is R1 and R2. If you need to type in an equation, into an equation, or refer to it, it's going to be in. All right, let me put this back on the board for you folks, all right? So I'm trying to do number 10 here. Number 10 has R3 is R1 plus R2. I don't have an R button, I just have the theta button. So you need to go to vars, okay? Y vars. And we are in polar in this case. If you want to refer to your y functions, you go into function, and then you can pick your y functions. Right, so this is how you would plug in a single number. Let's say you have your function in y1, and then on the home screen you want to say, hey, what is that function of, what happens if I plug in 3? You'd use this to type y1 parenthesis 3, right? Function notation. So, so don't want y1, I want R1 plus bars, y bars, polar R2s. There we go. All right, now I gotta set my window. Goes back over here so I can see. It's supposed to be theta 0 to 2 pi, step of pi over 24. Is that the default here? We'll find out. Pi over 24? Is that the same number it was? I don't know. And x from -7 to +7. Scale 0. Y -4 +4. And here we go. Oh gosh. What is this monstrosity? Look at this crazy thing. Isn't that wild? Huh? Told you the polar graphs are cool. What is some kind of crazy star-shaped thing? Yeah. That's fun. I wish we could spend more time with polar. Maybe towards the end of the year. We'll go back to polar graphs. They're cool. Now that I've got at least one example done in the video, we've got 10 more minutes to work. I'm going to go ahead and wrap up the YouTube stream here. So there's the video of the class. Just to continue to work on those problems. And thank you all for tuning in. We'll see you another time.